Hey everybody, welcome to Calculus again. Yesterday we did an example where step 1, plugging in, didn't work, and step 2, canceling a common factor in numerator and denominator, didn't work. So we had to go to step 3. Let's look at another exercise like that. First thing we do, we try plugging in. And we plug into So let's see, we have 8 plus 4 on top, and we have 4 minus 8 is negative 4, plus 4 is 0 on the bottom. This is no good. We're dividing by 0. So we go to step 2. But we try canceling a common factor in numerator and denominator. Excuse me for just a second. I apologize for the interruption. I think maybe I need to take that cell phone of mine and just throw it in a lake somewhere. Anyway, back to what we were doing. We tried plugging in, we got division by 0. So we go to step 2, cancel a common factor in numerator and denominator. That's no good in this case. The canceling trick only works when step 1 yields 0 over 0. And in this exercise, we didn't get 0 over 0. We got 12 over 0. We got non-zero over 0. So step 2 is not going to work. So we go to the dreaded step 3. It's not that bad, trust me. But step 3, analyze the one-sided limits. And remember in the last lecture I said, even though I know that canceling a common factor from numerator and denominator is not going to work. I still want to factor the denominator. That's going to help. And it's going to be especially helpful when it comes to graphing these functions. So I'm going to factor the denominator. Now, this is a polynomial. And when I plug in x equal 2, I get 0. What does that tell me? Do you remember? If I take this polynomial and I can make that polynomial equal to 0 by plugging in x equal 2, that tells me what? That x minus the number that makes it 0 is a factor. So if I plug in 2 and that makes this thing 0, x minus this number is a factor. Okay, so I have x minus 2 as a factor. And then we'll look for the other factor. Let's see. Whatever goes here has to be something that when I multiply it by x, I get x squared. So what's going to go here? It's got to be x, right? X times x is x squared. And whatever goes here has to be such that when I multiply it by -2, I get +4. Well, wait a minute. That would mean I'd have to have -2 here. -2 times -2 is +4. Yep, that works. Okay. As x approaches 2, what happens to x cubed? It looks like 2 cubed, doesn't it? It looks like 8. So when x approaches 2, x cubed plus 4 looks a lot like 8 plus 4. So for all practical purposes, the numerator is 12. Now, as x approaches 2 from the left, x minus 2 is going to go to 0. But it never actually becomes equal to 0 because x never actually becomes equal to 2. But it gets arbitrarily close to 0. So, do you remember what we do in a case like this? We represent it with an epsilon, don't we? Where epsilon is some tiny positive number that's approaching 0. The only thing is, this factor of x minus 2, I don't know if it's positive or negative as it approaches 2. So let's see. X approaches 2 from the left, which means that x is to the left of 2 on the number line. So that means x is less than 2. And I want to convert this to an inequality that tells me about x minus 2. So I can do that by subtracting 2 from both sides. And there I have it. As x approaches 2 from the left, x minus 2 is negative. So both of these factors are going to be negative epsilon. Okay. Well, negative times negative is positive. So that's really just 12 over epsilon squared. We have positive divided by positive, so that's positive. And we have a big number, 12, divided by something that's going to 0. Big number over little number, and that little number is going to 0. So what happens in this case? Do you remember? Doesn't it go to infinity? So that's our left-sided limit. And now we'll do our right-sided limit.